Good morning, everyone. Hope you're all enjoying Ignite so far. Today I'm going to be talking about how you could harness the power of RTX AI PCs to elevate your next generation of AI applications on the PC. My name is Annamalai Chockalingam, and since that's a mouthful, most know me as AC. I'm a senior product and marketing manager as part of the NVIDIA GeForce software team. You can ask me anything about generative AI and NVIDIA RTX GPUs. AI on PCs is one of the most evolving and recent developments. AI is being incorporated into every major app and will impact nearly every PC user. This all started 6 years ago in 2018 when NVIDIA first launched the RTX GPU with dedicated AI hardware called Tensor Cores. And this was the first widely deployed AI PC. It first came to market focused on enhancing gaming use cases with our DLSS software for super resolution and frame gen. With this, gamers get up to 4x faster frame rates using AI to generate pixels and frames. Since then, we've been at the forefront for AI for content creation with image conditioning models, AI for video conferencing and live streaming, AI for consuming streaming video, and now AI for productivity with LLMs and stable diffusion models coming into the foray. Today, there are more than 500 AI-powered apps and games that are accelerated by RTX across a wide variety of use cases. So you might ask why run your AI on a local RTX AI machine? First is that you get maximum performance on your PC. It's the fastest local AI accelerator with up to 1,300 TOPS at the top end. Second, we have the broadest ecosystem of developer tools and models and software. Today, almost every model published on Hugging Face works natively on our RTX platform if it fits within the memory. Second, and more so, it's also by running AI locally on your PC, all your data and models can remain on device and it's private and confidential. We also have the widest install base of the most performant AI accelerators on PC with over 100 million PCs already in users' hand. And lastly, it's local, it's always available. You can run as many inferences as you want on your PC without incurring any incremental cost. So the AI, this is the new landscape of AI accelerators for the PC. We see a future where some AI runs on the cloud where there's a need for a lot of compute power, while in other instances, the AI runs locally closer to you on your device. The growing demands of AI have created an opportunity for a lightweight AI processor with the NPUs, which deliver up to 45 TOPS per second. And this is suitable for lightweight use cases where battery life is important. For more demanding use cases such as gaming, content creation, development, and productivity use cases, GPUs on device are a great choice. They deliver up to 1,300 TOPS, delivering up to a 30x increase in raw performance. And for AI that's large and even more powerful that won't fit on a PC, like things like GPT-4, you can run it on NVIDIA GPUs in the cloud where you have effectively unbounded performance at scale. This is NVIDIA's developer platform for Windows AI. This platform is designed to help developers deliver high-performance AI capabilities across a wide variety of use cases. And it represents over a decade of investment in research and technology that is what it is today. It all starts with our GPUs at the bottom. Mathematics is the core of modern AI, and it all starts with matrix multiplication. And that's why in 2018, we fundamentally changed our architecture to incorporate tensor cores, which are designed to accelerate these matrix multiply operations. We made this change, and today, these GPUs can compute up to 1,300 TOPS, making them the fastest PC AI accelerators. And they also represent the world's largest base of dedicated AI installed hardware on the PC, with more than 100 million PCs worldwide. On top of the hardware, we have many libraries and SDKs targeted at different workloads to make it easier than ever for developers to leverage the technology. First is the inference frameworks from DirectML to Llama CPP to PyTorch and NVIDIA's native TensorRT. Sorry. Next is the SDKs, right? These AI models and the projects kind of come together into SDKs to help developers make it easy to integrate AI into various applications. So things like ACE for digital humans to DLSS for gaming and ray tracing and graphics workloads has led to the rapid growth of AI adoption on the RTX, with over 500 AI apps and games all accelerated by RTX today. So RTX accelerates a variety of AI inferencing backends based on your needs today. First is DirectML and Onyx runtime. DirectML is great for Windows-only PC deployment environments, offering cross-vendor support across the breadth of Microsoft's PC ecosystem. And it works right out of the box with GPU acceleration. Second, TRT is often a great choice for many developers. It features the latest features as well as it's the best way to get the maximum performance on NVIDIA GPUs. And the same backend works across cloud and PC environments within NVIDIA GPUs. We also support Llama CPP, which is emerging as a great community-supported backend for the latest LLM-based models, and it's often great for cross-OS, cross-platform support with the latest models, and it's completely open source. And lastly, we have PyTorch CUDA, which is great for experimentation and development within the same framework as your training framework. It's cross-OS and often works everywhere. So this showcases the breadth of software that's available for developers to build AI into their applications, from audio effects SDK to ACE for bringing AI-powered digital humans to applications, to optics to reduce noise in 3D ray-traced renders, to RTX video for upscaling and color remapping, and Maxine, which brings AI-powered capabilities for teleconferencing and augmented reality applications, and as well as DLSS to increase frame rates in video games and 3D creator applications. This NVIDIA ACE is a suite of digital human technologies that brings characters to life with generative AI. It consists of NIM microservices that's used for deployment across cloud, on-prem, or PC. And this suite includes a pipeline of different models, from Riva for speech to Nemotron for intelligence and language generation, and audio to face for animation workloads. And this suite is compatible with the most popular rendering and game dev engines, including Unreal Engine 5, as well as NVIDIA's own Omniverse RTX renderer. So, generative AI is creating huge opportunities for Windows application developers, and the stage is set. Models are becoming larger and larger and becoming more powerful, with LLMs and diffusion models unlocking new use cases. And there are many, many high-quality open-source pre-trained models, foundation models that are ready for developers to use, and new ones are launching every single week. But it's sometimes a little challenging for developers to bring these models onto the PC. Pre-trained models are predominantly general purpose. They give good responses about general topics, but they're primarily designed for data center. So you kind of need model customization tools to make your models application specific. Then developers often face the challenge of, okay, how do I fit this within the constraints of a PC, within the memory requirements across different kinds of PCs. So developers often need to optimize their models to make it performant and quantize it and make it smaller for their use cases. And lastly, there's thousands of end-user system configurations from very powerful RTX-enabled PCs to PCs with only CPUs. And app developers need to design across all scenarios to ensure an optimal user experience. And oftentimes, this can include many different kind of deployment configurations, wherein developers run into software and dependency management challenges. So we offer an end-to-end pipeline to bring, to solve these exact problems, and it offers, we offer a collection of tools across the workflow to build and deploy AI models into RTX PCs. This includes tools for model tuning, such as RTX AI Toolkit, which can run entirely on device using techniques like 𝗬𝗫𝗓 from Hugging Face transformers, to tools for model quantization optimization with tools like TensorRT Model Optimizer, which can compress and optimize your models to enable smaller models and faster models on the PC. And lastly, there's many different on-device inferencing options that we support from Onyx Runtime, Llama CPP, and TensorRT. So, this is kind of, so how does this work in practice? On the left is a pre-trained model like Llama. And if you use this out of the box in a code generation use case, you can see it doesn't work too well. It provides kind of a generic response, and it runs relatively slowly. And you need, at least an RTX 4090 to run it. On the right is the same model that we've customized and optimized with the suite of RTX tools. And you can get up to 4x faster and 3 times smaller models with RTX that provides more accurate responses for your use cases. So this is kind of RTX AI Toolkit. It's a way to customize models using fine-tuning techniques on device on the RTX PC. So this uses a parameter-efficient fine-tuning technique called 𝗬𝗫𝗓, which fine-tunes a small number of extra model parameters while freezing most of the parameters of the base pre-trained LLM. So only a small number of parameters are tuned while the rest of the model is frozen, greatly increasing the performance and the accuracy of the model. The 𝗬𝗓 technique generates new layers that are plugged into the model at runtime, so you can kind of replace it and build multiple adapters to serve different use cases, all with a single foundation model. So you can have a base, like a Llama model, and then add different kind of 𝗬𝗓 adapters to serve many different applications on the PC. The next step is model optimization. As you know, running LLMs on local devices efficiently is limited by the memory available on the PC. Enter TensorRT. TensorRT Model Optimizer. LLMs require memory bandwidth, and they need to be compressed to fit onto the PC. TensorRT Model Optimizer helps with this by compressing the model weights to minimize the footprint with techniques like quantization. And second includes compiling the models to access hardware-specific inference optimizations to further improve the performance on both latency and throughput. This involves building optimized engines on the target hardware to accelerate performance, and this can all be done on device. And this results in up to 2.9x faster models with minimal accuracy degradation, with up to 2.6x smaller models than FP16 when you're compressed down into N4. So the outcome of all this process is kind of shown here. After all these steps, you can get models that run super fast across the breadth of the RTX PCs across the product line. For example, the Llama 3 model runs at over 150 tokens per second on an RTX 4090. So what does this kind of mean for real-world applications, right? How do you kind of bring all this together into something that an end user can use? And one example of that is Chat RTX, which we which is a retrieval augmented generation-based chatbot where users can upload their documents and ask questions to further understand more about the topic, all running locally on their RTX PC. And this is a completely open source developer project as well, so you can go on GitHub and check it out. Check out how this project was built and make it your own as well if you so want to. Let's see Chat RTX in action. Can we get audio? Audio on the... No audio? Okay, maybe I'll just talk through it, then it's all good. So this kind of first showcases how you can chat with the model using Chat RTX. So we've just asked it a question, generic question, about AI Summit that recently happened for NVIDIA, and it gives you a generic answer, which is not accurate. But now when you upload the document and ask it a question, using retrieval augmented generation based on this document that is being uploaded, you'll see here shortly that I think we're uploading the website of this into the bot. And now if you ask it a question, it'll give you a much more precise answer and cite exactly where it came from. And now you can have a full-on conversation with the system. Yeah, and now it also supports clip-based models, so it can understand images as well. So you'll see that. I guess that wasn't working. And this showcases RTX
Building
AI
and
toolkit.
deploying AI models into apps running on PCs poses a challenge for developers. First, models need to be customized for application-specific needs. Second, models need to be optimized for a wide range of hardware to deliver top performance. Finally, developers need a deployment path that works across cloud and on-device AI. NVIDIA RTX AI Toolkit offers a collection of tools and SDKs to help PC app developers customize, optimize, and deploy AI models to Windows applications. Let's take a closer look at the workflow and show how developers can deploy a custom LLM model into a Windows application. The first phase is model customization. We can do this using NVIDIA AI Workbench, a tool to organize and run model customization and optimization projects across platforms from cloud to RTX PCs. With AI Workbench on RTX PCs, we can customize popular models such as the 𝗲𝗲𝗀𝗲𝗏𝗏𝗏. Here, we use custom data to improve model quality for specific use cases. In this case, we want to make Llama 3 better at generating NPC dialogue for a fantasy RPG. We'll use roleplay instruct dataset, which contains 2000 instruct follow data generated with the alpaca format. Under the hood, we are going to use 𝗬𝗓𝗓, a parameter-efficient fine-tuning technique that runs on consumer RTX GPUs. We leverage Llama Factory and the Hugging Face Transformers library to tune the Llama 3 model. The time it takes to train and the VRAM needs will vary with model size. The next step is model optimization. Since LLMs tend to be memory limited, we need to minimize the storage footprint of the model. With quantization, models can run on a breadth of devices that have limited VRAM. We do this using the TensorRT Model Optimizer library. Now let's look at deploying these models into apps with NVIDIA AI Inference Manager, or AIM. AIM simplifies AI integration into PC apps and orchestrates AI inference across PC and cloud. AIM supports multiple inference backends, be it TensorRT, ONNX Runtime, DirectML, or Llama CPP, and also supports different accelerators. With AIM, we can use NVIDIA NIM to deploy into the cloud or enable on-device deployment with native C++ plugins. Let's now plug this into a chatbot and start interfacing with the model. On the left, we can see the base model, and on the right, we can see the 𝗬𝗫𝗀𝗏 customized model in action. Clearly, the customized model shows improved performance of NPC dialogue generation. Overall, RTX AI Toolkit offers a seamless workflow for Windows app developers to integrate AI functionality into PC apps. Get started today by visiting developer.nvidia.com/rtx-toolkit.
All right. So leading organizations are choosing to adopt RTX for their AI workloads on the PC. We have over 125 leading creator apps accelerated on RTX today, some of which includes the likes of Adobe, DaVinci Resolve, and Topaz. And the most popular developer ecosystems are also choosing to integrate the goodness of RTX. Now you can access your favorite developer tools as well on RTX, from LangChain to Llama CPP to Automatic 1111, et cetera. And all the major OEMs are also building and shipping PCs with over 100 million RTX systems worldwide. So here's a way you can kind of start your Windows app integration today using some of our tools. Here's some resources for you to get started. And as a summary, RTX AI PC offers a compelling platform for you to build on. It offers the broadest ecosystem with over 500 games and apps that are accelerated with AI and shipping today. It also offers the fastest performance with up to 1,300 TOPS of raw performance. And lastly, hardware performance only matters if you have all the developer ecosystem and tools to support it. And we've been investing in our entire stack, and we have a full accelerated computing stack to build to help developers easily build their applications on the PC. And lastly, RTX represents the largest install base of AI PCs, and NVIDIA has been shipping dedicated AI cores since 2018, and now there are over 100 million RTX PCs worldwide. Thanks for attending the talk. Appreciate your time. Happy to answer any questions if you may have, and we're also up at the booth in Zone 3.
I don't know if it's working. I have a question.
Yeah.
Any chance that RTX PCs will turn to Copilot plus PC in the future? Because there is a lot of TOPS on the
Yeah.
PC.
Today, I mean, it offers an AI accelerator. We're working on that. We'll see what we can do on that front. I don't have any more information to share right now, sorry.
That sounds great. Thank you.
Any other questions? Yeah.
Can you use these tools to capitalize and improve Autodesk and Esri models?
Sorry?
Autodesk and Esri models?
Autodesk. Well, I think most of these tools are meant for generic AI models. So I don't know specifically about the Autodesk models and what the models that they use. But I'm sure we can have a conversation on the specifics.
Will these only run on GeForce cards, or will they run on anything that's RTX?
Anything that's RTX. Any other questions? Happy to stay back and have a conversation as well. All right. Thank you all.